Hi, welcome along to the OWASP meetup. Thanks everyone for coming. It's great to see good turnout. Hands up if this is your first time coming. Cool, welcome. It's great to see you here. So OWASP is an open web application security project. Started like ages ago. There's a big wiki at owasp.org, and OWASP is famous for the OWASP Top 10. And there's a bunch of other projects as well, but that's their sort of flagship one. We've been running the meetup in Wellington for a year or two now. Well, actually, it's been going more than that. And what we're trying to do is focus on the common web security problems and sort of dive into each of them, give an introduction, and really help you build more secure web applications. Every year we run a conference, which is the OWASP Day in Auckland. So we've had it for this year. Next year will probably be in February. And that's a free conference, so hopefully you come along to that. And there's other conferences around which might get Eric to talk about at the end. So what else? Vales. So I've had the pleasure of working with Vales twice now. I worked with him back when I was at Xero, and then more recently since we both joined Red Shield. He's a former application developer, software developer, then pen tester, and now a fellow Red Shielder with me. But this talk's not a sales pitch, it's just he was sitting the closest when I was trying to find a speaker. So today's going to be talking about CSRF. So over to you, Babs. Let's clap. So.
Okay, so yeah, Kirk already introduced me. I'm on Twitter at Vales Bakaitis, and interesting. I'll publish the slides, and maybe Kirk can put that on the meetup as well.
Yeah, just as a link.
It's all going to be in HTML. And they were talking about Cross-Site Request Forgery. So before we begin, I would like to go back before the web was created and just talk a little bit about how everything came to be, because it is important to set the context. The web, as we know, started somewhere around 1989, 1990 at CERN. It's an institute, they do research, and at that time they had a particular problem where they had computers and you could create a document with your computer, but if you wanted to share a document with somebody, you would have to write it to some kind of drive and give that to them. And also, that was a bit of a hassle, but also if you use different computers, if you use different operating systems or different software, there was no standard for interchanging information easily. So one guy called Tim Berners-Lee came up with this concept of hypertext, or rather adapted the concept, because the concept was there since probably 70s, or maybe since even earlier. He just went on and formalized that into two protocols, that is HTTP and HTML. HTTP is a transfer protocol, so that's network protocol, and HTML is the file format. And what he was trying to achieve by doing this is to have a way of serving a document on the web that has links to the other documents. This means that there's no images, no interactivity, nothing. It's just text, and on some words they're highlighted that you can click, and you're going to get to go to a different document. So this is what it was intended for, and this is where it all started. Slightly later, in 1993, they open sourced the World Wide Web library and allowed other people to use it. The adoption was very, very quick, and before they knew it, all these different browsers started sprouting up, and they started implementing and suggesting different features. In 1993, Mosaic browser suggested implementing an image type, or displaying images inline in your document. They had some interesting formats. I was reading mailing lists there. And some very interesting discussions. For example, one of the discussions was when they announced the support for this, somebody said, your browser doesn't have a TCP/IP stack, so how people are supposed to do networking? And they were saying that, no, this is not nonsense. TCP/IP is not it shouldn't be an issue for the software, it should be an issue for operating system. Because back then it wasn't, the TCP/IP wasn't even part of operating system, or wasn't the standard library. So if you read those mail archives are still there and are still available. So it's quite interesting to read those. After images, forms were introduced in 1994, and these forms allowed to submit information back to the server. So before 1994, you could only request from server for a document, and the server would serve it. That's it. You had no way to submit feedback to the server. Forms allowed that. And then, again, 1994, cookies were also introduced. Cookies were introduced by Netscape. And I don't know if they had a particular vision for the cookies, but the first use was to track whether somebody visited their website. So it was only implemented in Netscape browser and in Netscape server. And when you would use Netscape browser to visit Netscape website, they would know that you've been there before or you haven't been there before. And then in 1995, JavaScript was introduced, or rather written in 10 days. And again, the adoption was very quick, and I've had a couple of exchanges with the creator of JavaScript, and he basically said that there were some things that he wanted to change after creating JavaScript because he saw that that might be problematic. But by that time, already so many people were using it that they did not agree to that, and he didn't get a chance to do that. So again, a very, very quick adoption. And what JavaScript gave is it gave the interactivity to the web page. So the web page could do stuff in the browser. It moved being from a document to an actual program in the browser. Also, before we start talking about Cross-Site Request Forgery, I just want to talk about how different parts of the web work. So at the very basic, we have browser, which acts as a broker between user, the website, and the server. So the website is like a program that's running inside the browser, and the browser does two things for the website. It provides the runtime, which is rendering in your JavaScript runtime environment. And it also provides APIs. So if the website wants to do anything, it asks the browser to do it, because the website cannot, there's just no other mechanism for it to do anything. It always has to ask the browser, and then the browser performs the action for the website through the APIs. And the same thing with the user. The user might interact with the browser itself. For example, when you're entering a URL in the address bar, you're not interacting with any particular website, you're interacting with the browser. And so then browser will go and fetch that website and render it for you. But after that website is rendered, now you're interacting with the website. If you're pressing buttons, first of all, you're interacting with the website, and the website is going to pass that to the browser. And the browser is going to do that in runtime. So both websites and users can perform actions in the browser. Users obviously can perform actions in the browser through pressing buttons, typing something in, moving the mouse. Websites can perform actions in the browser through JavaScript. So when you have JavaScript running in the website, it can do pretty much anything a user can do. It can click buttons, submit forms, type in the input elements, all that stuff. And as far as the server is concerned, the server doesn't really know what is happening in the browser. That is, the server just gets a request and sends a response. And in between that, the server doesn't really know what caused the request to be sent to it, or what particular action happened in the browser. So in the light of all of this, let's talk about cross-site request forgery and how the attack works. So we'll start with the user and with the browser. So user opens a browser and decides to check their bank account. So it goes to internet banking, enters the address in the address bar, and browser takes that, figures out what is the server through DNS, gets the IP address, connects to the server, and sends the request to the server. So first request is usually get, doesn't really send that much data. The server will generate some kind of page. We'll send that page back to the browser. The browser then will render that as a website to the user. And that website, if you're visiting an internet banking, is usually a login page. So that website usually would ask the user to log in. The user then would enter the login details into the website, click a button, and then JavaScript event fires or a form is submitted. And that website asks the browser to do something, to submit those credentials to the server. So the browser sends the credentials to the server. The server checks the credentials, and if they're correct, it will send back some information, maybe a list of your accounts with all your funds that you have in your bank accounts. And also, with that response, it will also send a cookie. And this is required because you don't want to be entering your username and password every time you log in. You want that persistence, and the cookie is what gives that persistence. The cookie is saved in the browser, and these days they mostly have flags such as HTTP only, so they don't really get passed to the website. Only the response is rendered again in the website, and that is presented to the user. So far so good. Now the user checked their bank balance, saw that they have a lot of money, and were all good. Decided to visit a different website, same browser. They asked for some bad website, I don't know, malicious website address without knowing what it was. The browser does the same thing again. It resolves the name, connects to the server, sends a GET request, and the response is returned back to the browser. The browser then renders the website. And this is where it becomes interesting, because the user doesn't really have to do anything in that website, because as I said previously, websites can do all the same stuff that users can do. So this website, without any user input, can say, perform this transfer in this bank, and ask the browser to pass that request along. Now the browser, it will take the request and it will inspect the destination domain or origin rather, and it will see that it has a cookie for it. So it will automatically attach that cookie to the request, and it will send that to the bank server. And the bank server, since it's using the cookie to identify the user, will see the cookie, check the cookie, it's valid, there's a request to transfer money, and it will perform the transfer. So this is how the cross-site request forgery attack is performed. Now, obviously, that's a very undesirable outcome, and we need to figure out a way of how to fix this situation. So talking about the protection, because of the way the web has been created or evolved to be, it wasn't really designed to do what we're trying to do. So the protection against cross-site request forgery is also the most common at this point. It's slightly interesting. So we have same scenario: user makes a request, browser talks to the bank, renders the website, login is passed down to the bank server. But now, instead of just sending cookie, the bank server sends a cookie and a token. And a token can be either a parameter in the form destination form URL. It can be a hidden parameter in the form. It can be some other kind of token somewhere in the DOM. And this is how it works. So the browser still keeps the cookie, but the token is passed to the website. It's rendered in the website as a form field or some other type of element, might be a bit of JavaScript. And the website has that attached to it. So now when a user makes a request to transfer the money, the user does that through the bank website, which already knows the token. So the bank website passes that token to the browser. Browser then attaches the cookie that it has and sends that to the bank server. And bank server can verify both of those, the cookie and the token, and can see that everything is fine and perform the transfer. Now, if we have the same bad website, what will happen is that the bad website will ask to perform the transfer. However, the bad website doesn't know the token, and the browser will not attach the token automatically because the token is on a different website. And the data doesn't really flow between websites because these are different origins, and origins are very separated, usually, unless explicitly stated otherwise. You usually can't interact with a different website that easily. So the browser will still attach the cookie, but the bank server will check for the token, will see that there is no token, and will refuse to perform the transfer. So this is how it's most. This is the most common defense against cross-site request forgeries today. Now people realize that this is not ideal and that there should be some better mechanism. Quite recently, a SameSite cookie flag was introduced. And this flag is a flag that you can set on a cookie to indicate to the browser that this cookie is meant to only be used in the same site. That means that whenever a request from a website is received by a browser, it will check whether it's the same website or whether it's a different website asking to perform the request. And if it's a different website, it will not attach the cookie. The support for this, however, is not that great at the moment. I think only Chrome, Opera, and a couple of Android browsers support that. So it's not quite ready yet, but hopefully sometime soon. Now, some side effects can protect against cross-site request forgery, and this is largely due to the same origin policy. Same origin policy imposes a lot of restrictions on what websites of different origin can do. For example, you can, when you have a website, you can make a request to any other website by means of submitting a form or just sending it as an AJAX request. However, you're not allowed to read the response of that. The browser will not show you the response. And you're not allowed to do any kind of funky stuff like setting headers or setting different setting specific content type. So if you have content type application JSON, that is not susceptible to cross-site request forgery. This doesn't mean that it should be used as a defense, because it's a side effect and not, it's not actually designed to do that, so you shouldn't rely on that. But if you're testing some website and you can get cross-site request forgery working, you need to make sure that that you're not trying to send it through application JSON, because it's not going to work. Any kind of custom header, you're not allowed to do that cross origin, so the same origin policy applies. And at the server end, a potential way of defending against this is to check the origin header. An origin header is generated by browser, and that's why it's somewhat trusted. That is, whenever you receive, whenever the browser generates a request, it will put origin header with the URL of the website that has requested to perform that request. And so you can just check the origin, and if the origin is not your own, then you might want to consider discarding that request. And obviously, even if the website or the server does not have adequate protections, you might want to protect yourself as a user when you're browsing your internet banking. Even if they don't have Cross-Site Request Forgery protection, you still want to make sure that somebody doesn't take your money. So there's a couple of ways of protecting yourself. We all know about Incognito mode. So if you open Incognito mode and go to your visit your bank or dodgy websites, sort of as a form of isolation there, it's fine. However, you cannot visit both because Incognito mode shares one session. So if you visit both your bank and a dodgy website in an Incognito mode, you're back at square one. it's still the same. Dedicated browser profiles. So at least Chrome offers the ability to create a browser profile which essentially acts as a different browser. So if you have two profiles, they essentially act as different browsers, and your cookies are not going to be shared between those. So what you can do, you can create dedicated browser profile for checking your bank or doing any other sensitive stuff. And obviously, when you're checking your bank, go and don't start torrenting, downloading torrents or doing whatever, any kind of dodgy stuff.
But it could happen in tabs that you've got open already, right?
Yeah, that's right. So whatever tabs you have open, JavaScript is always running there, right? It's always active. So the fact that you had it open from previously doesn't save you. And that's all we have. It's reasonably short, but I think the subject is really simple as well. Any questions?
Can you talk about places or apps that have had cross-site request forgery issues?
So like CPEs?
CPEs?
Routers.
Sorry?
Routers. Your home router, your DSL router.
Yeah.
Most of the older DSL routers don't have CSRF protections, or if you don't change the default passwords, people can use CSRF to log into your home router, basically.
Yeah, that's right. Yeah.
That kind of stuff. So,
yeah. So that's one example, and that's especially dangerous because you're letting people inside your internal network.
I mean, you've got if you access like any website that can run JavaScript in the browser,
yeah,
they can then access your home router if you haven't changed the user and password on.
Yeah.
So.
In the past, it was really prevalent in Facebook and other social networks. There used to be websites that you visit, and suddenly it starts liking stuff on your profile, and then starts sending messages to all the different people just through having hidden patterns and hidden input fields in that other website. But it seems that they have sorted it for now. I'm sure it's in many other applications. If you have a look, if it's a simple form, if it doesn't have a custom content type header, and if it doesn't have a secret value, it's vulnerable to this attack essentially. And any website that you visit at the same time can perform that action on behalf of you. Yep.
The question actually about a story. A year ago, it was a bug in JetBrains IDEs.
Mm-hmm.
It was like unauthenticated local port opened, which led to remote code execution. Because of the very same problem, because an arbitrary web application could send requests there and act as a user of the user's machine.
I forgot to point out we're recording the talk, so hopefully people that have asked questions are okay with that. Otherwise, if you're not okay with that, just come and whisper in my ear and I'll repeat it. So you're talking about, I guess, web servers being opened on your computer. And you're talking about web servers on your router.
Yep.
But pretty much any web framework that is old won't have CSRF protection built in, so it won't have that secret token in it. But the newer ones do, I think. So
Most.
Yeah.
yeah,
And some web frameworks, I think, if you're developing for WordPress, there's a way of building in the Cross-Site Request Forgery protection if you have plugins or themes, but it's not done for you, so you still have to do it. There's functions that you have to call and that you have to check, and so there's plugin developers have a different level of understanding of security, and so some might think that going and doing such protection is redundant, and you get plugins that are vulnerable.
So with like the banking situation, is it only if you have two tabs open, say you're banking with yourself authenticated and then you go on the dodgy website, but if you were to close your banking tab, are you still vulnerable in that?
Yep, because the cookie is still there. Think of it this way: if you close your banking tab and if you open it again, are you still logged in?
I don't think so. I hope.
It depends how they're handling, right? Because they could have some kind of callback in JavaScript on closed window to clear the cookie and so on and so on. So if that's the case, sorry, you're fine. But if they don't do that, then that is vulnerable.
Yeah, lots of apps will have 30-minute cookie life. So on that picture that Vales had, the cookie will stay in the browser for 30 minutes, even if you're not using that website.
So is that the developers setting the cookie time to like time to live kind of thing, or is it just when you have like a session cookie and you close the tab, it's completely dead, or is it actually up to developer how long that cookie persists?
No, it's up to developer.
Yeah, nothing disappears when you close a tab, unfortunately.
Yeah, think of it like when you're on Facebook and when you close the tab and you open your browser again and it's still logged in. The only way how it can know that it's you is through the cookie.
If you erase the history and erase the cookie,
yeah,
that will be erased.
Yeah, that will be erased. Yeah.
Can you think of any scenarios where you need both same origin policy enabled and CSRF token?
Well, same origin as a policy that applies to every website. It's enforced by. Oh, you mean the cookie flag? Sorry, I got confused there for a second.
SameSite.
SameSite, yeah, it's SameSite flag. Well, I guess at this point we're in a situation where it's not supported by every browser, and even a year or 2 or 3 years later, there might still be people who haven't updated their browsers, and they're still on a browser that doesn't support the flag. So I would say you have to kind of use both.
Taking the case of social media sites, if you had the SameSite cookie flag enabled,
yeah,
and someone got you to click on a link just by sending it to you, would that defeat the SameSite flag?
No, so
depends where you receive the link through, because that's going to be the origin.
Yeah.
So if you click that link in your Facebook, so if it's a Facebook cookie, and if you click the link in Facebook, then it will send the cookies. If you click the link in some other application, then it won't.
Yes.
But then again, hopefully Facebook does not allow you to perform actions simply by visiting the URL.
Yes, social media was just the easiest way I can think of. That someone would send you a link and you'd be like, oh yeah, I'll click on it in this chat message window thing that's on the website.
And that's another interesting aspect there, is that before people didn't really pay too much attention whether they use post or get requests, and they kind of use both. But the further we go, the more we realize that it's really, really important when you're making changes in the application or performing actions to use post request or put or whatever you choose. But because get requests is meant to say, I would like to visit this page and give it to me. It does not indicate the action.
All right.
So one of the things that I noticed is that if you have a CSRF token or that SameSite cookie, there's no way to assert that those were actually working really to the user. Like, you could, like for the CSRF token, it could just be discarding it, for instance. There's no way to assert that, right?
So
you can check, right? I guess you have to have
Yeah.
really good understanding of the whole
Yeah.
deal. But yeah.
So we'd need some sort of like user-facing thing to tell them that they're using SameSite cookies or something like that, because I mean people just won't know.
It's interesting. Possibly, I don't know.
Users normally trust that
Yeah,
the website they're
yeah.
using is secure.
Yeah.
I guess the person that would normally verify it would be the
Right.
internal test team, and maybe some external testing, like pen testing. And so the way that I used to test it is just right-click on the page and go inspect, find the CSRF token wherever it is, like it might be a JavaScript variable or hidden field, and just twiddle with the values.
Yeah.
And then try and do whatever I was going to do, and it should
If it
fail.
still works.
If it still works,
But then
it's
you
a
have to
bad
rely
sign.
on the application developers to get that or to actually test that.
Yeah.
Well, you kind of have to. I can see the browsers like Chrome taking that into consideration eventually, like they do with HTTPS and mixed content. I can see them putting that in the mixture as well. But then it becomes quite technical. At what point is it too technical for a regular user to understand?
And is fiddling a CSRF token on your banking website and then trying to do a transfer, when that's probably going to throw up an alert on your security system. Like, is that something you're actually allowed to do? Because you're trying to circumvent a security mechanism. I don't know where the law goes there, but
I think it's fine if you're doing that on your own bank account, on a different bank account, then maybe.
okay, I would have said not, but you should consult your lawyer.
It also depends on how the CSRF tokens are generated. If they're true random versus if they're not quite random.
Yeah.
There have been vulnerabilities where you can generate CSRF tokens because they weren't generated randomly to attack sites.
Yeah, and also I should probably mention the proper way of doing that is to generate a token for each page. So every time you use a page or that has a form, it has a different token, and that ensures that it's more.
You generate that randomly secure, like a secure random thing, not just a.
Not just a number.
Not NT-rand in PHP.
Yeah.
So.
The best thing is you use someone else's library that's already tested.
Yeah, and
You just mentioned, to generate it on every page.
Yeah.
So what's your personal feeling whether it makes a real protection or it's just a placebo? That if you generate it on every page, it adds any to security.
I'll tell you why it makes sense. Because say you're on Facebook and you want to change your email address on Facebook, right? If you never visited the settings page, you should not be allowed to do that because there is no way for you to do it.
No. I thought you said on every page. Does it mean on every kind of form or literally?
On every kind of form. If you don't have any, if there are no options on the page to perform an action, you don't need a Cross-Site Request Forgery token.
Yeah, because
on that page.
Because a lot of people implemented like on every page they generate a new token.
Yeah, sometimes it's just easier that way. And again, tying the token to the page as well. So for example, if you visit a settings page, you get a token that is valid for that page. So you're not allowed to make a transfer with that token. You're only allowed to change your settings with that token or submit.
Most of the frameworks I've seen just give you one token for the whole site.
Yeah, just that's the most common.
But I guess that's not as strong as a separate one per form.
How are the tokens generated?
Using a secure random, pseudo-random generator. So depending on the platform, on Java and .NET, you would probably have secure random. On PHP, I can't even remember, but yeah, depending on the platform, and also depending on what framework you're using. So frameworks, different frameworks will have different ways of doing that. So for example, I'm pretty sure that WordPress has a way of asking, saying, generate a token, and then afterwards on submitting on verifying the request, you can say verify the token, and it's all abstracted away from you, so you don't need to worry about how it's generated or how it's verified.
Yeah, so the web server is generating the token when it gives you the page, and then when you send the request back, it's checking it. So yeah, it's the web server doing it as well. Yeah. Sorry.
You've talked about Chrome handling all of this quite well.
Yep.
How does Firefox stack up?
Other than the fact that it's not great at protecting cross-site scripting, I think it's about the same. I mean, it doesn't really, well, I guess Chrome has SameSite cookie flag support already, and Firefox doesn't. Opera does for some reason.
Opera and Chrome are based on the same browser? Rendering engine or something?
Yeah.
Interesting. Yeah. Not realize that.
Yeah.
But yeah, I would say it's the same. It's more of a flaw of the design of the web rather than a particular browser, if that makes sense, because the web was never designed to have any kind of authentication, authorization, and now we have not only that, but we have persistent authentication and authorization through those cookies. So it's just something that we're using that was not designed for that, and now we have to backport the security features that should have been built in there in the first place, and it's difficult.
Basically, the web never was designed to have a state.
Yeah.
If you don't care about state, if you've got something like self-destructing cookies, something like that, is that enough? If you're just constantly wiping cookies and you don't care.
If you're constantly wiping cookies, you don't have state.
Yeah.
But if you don't care that you have to log in constantly.
Well, if
then you're sending.
Refresh the page or click on a link inside the same site, that's you have to log in again.
Then you're sending your password every time you request a page.
That's basic auth, basically.
Do you know if there's any, like, for people that are real shit at logging out of things before they close a tab, do you know if there's any extensions that people can get that will wipe your cookies for a particular website if you close the tab?
I've known people that clear them every day, but no one closes their browsers every day anymore.
No.
Yeah. Some of those extensions, like NoScript, I think tighten up how cookies work, but I haven't used that myself.
And if you use Incognito session, whenever you close all of the windows of Incognito session, that is destroyed. If you have 3 windows and just close one, nothing happens, because even though it's Incognito session, it's still, there's one session under all Incognito windows, Incognito tabs. Which is interesting because in Chrome you can have different profiles which act as separate browsers, but I think you only get one Incognito session. So it might.
I think you get one per profile.
Do you?
Yeah.
Okay.
Yeah. You have to set that on the command line when you open up a new profile.
So I'm a profile fan. So on my browser, when you go to the people menu, which is where you get profiles in Chrome, I have one for banking, one for accessing AWS, one for accessing a VPN and a proxy and all that kind of thing. So that means that basically no other website can attack my banking cookies, because I only use that profile for banking, nothing else. So you should do that as well. Yeah.
You talk about the same browser on 2 tabs or something. What happens if you open that link in another browser?
Another browser has another set of cookies. It's not shared.
Yeah, some people do that as well. Like they only do their banking in Opera and they use Chrome for the web stuff. That's a pretty good defense.
I'm taking it one step further. I've got a Chromebook that's only used for banking.
Different computer.
Wow.
Yeah, Chromebooks are pretty secure.
That's cool.
I was actually talking about same origin, so I guess this doesn't apply to if you have same origin policy label. This is for cross origin.
So same origin policy isn't something that you can enable or disable.
It applies to all websites at all times.
It's just a built-in how the browser separates websites. So you might be talking about something else that can be enabled.
I mean, the request is coming from the same domain.
Yeah. So like if you had that picture of Vales of your diamond. Oh, hey, your animation's work backwards.
Partially.
Same origin means that bad website can't access bank websites, HTML, or read any responses.
Yeah, so you wouldn't need.
And the only way you can turn that off is if you allow origin with pause cross-origin requests, which is a JavaScript HTML5 feature.
So same origin breaks this connection. So there's no connection here unless you explicitly allow. The same origin doesn't mean that this cannot talk to that, because it can.
Yeah, they won't be able to call the JavaScript in the bank website.
Yeah, you can just use JavaScript, or you can have a form where you make the user click the button by putting, I don't know, a funny picture of a cat on top of it, and that form is going to be submitted through this. Now this can check the origin header of the incoming request, and we'll see which one made the request. But
I want to make sure that only JavaScript can call from my website. So I was wondering if I should look at same origin, or if I should look at this CSRF token.
Well, you shouldn't really. I don't think that matters too much, as long as you're checking your, either Cross-Site Request Forgery tokens or whatever else you're dealing with, right? If some other website connects to your server and makes a request, that's just going to go through your usual checks, and it's going to get discarded because they won't have enough information to perform a successful request. So, I mean, they still can do it. But
well, I mean, that still works if you have default password, username and password on your router. The JavaScript inside your browser can call that by the default IP address and can still do the bad things on your router. But again, you still need the CSRF token if you're logged in.
So
it can still do.
I'm sorry to jump in front of you. So when bad website connects to your bank server, it sends an origin header. So it says origin : badwebsite.com. So you can block that request on your application. You only want origin equals bankwebsite.com. So that's the origin header thing. But same origin policy, like Vales was saying, means this can't talk to that. But it also means that bad website can send a request to your bank server, but it can't see the response. So it can't see any secret tokens that the bank server is returning. It can only send requests. So if you're doing a transfer money request, you can send that request from bad website to the bank server, but you can't see if it was successful or not. And so that's the same with like logging in. If the bank server was your home router, a bad website could log into your home router. Your browser would get the cookie, but the bad website wouldn't be able to see the cookie. Normally, you'd be like, okay, that's fine. But if the bad website does another request, which is, change the password to something they know, or I don't know, start streaming stuff, or forwards and ports, or whatever, they can send that to your router. I think that's probably an edge case, messing with people's routers.
It does happen a lot, actually, so yeah.
But it's not something that most web developers would deal with.
Are you developing CPEs? Are you writing software that runs on people's routers?
No.
It's not restricted though. I used to how long then you'd have to authenticate and you'd have to submit.
So I mean, like how many people log out of their home router?
Pretty short. 30 minutes is pretty short. Yeah, I think it's the edge case.
And having a multi-step transaction is also, that doesn't stop anything. Because that website can just submit one request, wait for 30 seconds. That's going to be enough to finish any request. Then submit another one, third one, fourth one. Can be 20, can be 100.
Sorry for jumping out.
No.
I should check if there's any questions online. Is there any other questions from the floor before we wrap up? There's not any online. There's 5 people online. That was pretty awesome.
Is that right?
Yeah. You had like a pretty significant percentage of the internet. So hopefully that's given you a good intro to CSRF. Vales will hopefully hang around for a bit longer, and we can mingle. What else I wanted to say before Erica hops up, we've got a library of previous talks, so if you're new to the group, you can go to the meetup and see previous meetups, and there's videos for those ones, and then that might springboard you into looking at other stuff. You know, these are all nicely Googleable terms. Yeah, so let's thank Vales for his talk.